10, 11, and 12, we're doing the same, proving trigonometric identities. These ones just get a little more complicated. The more you do, the easier it gets, because there's just a lot of little things you have to look for. But in this case, I want to try to combine cosecant of x minus sine of x into cotangent of x and cosine of x. Again, usually I try to change things in terms of sine and cosine if I can, unless I see over here that I might have cosecant or secant, then maybe I might not do that. But in this case, I'm going to start out and I'm going to change my cosecant of x using my reciprocal identity into 1 over sine of x. That was my reciprocal identity. And then I look at that and say, geez, I want to put that together into one thing because I don't have the subtraction in there anymore. So I have to go ahead and find my common denominator and make this into one fraction. My common denominator is sine of x, so if I take this times sine of x and this times sine of x, I'm going to get 1 minus sine squared of x over the sine of x. And there, I just basically did algebra. Then I look at that and say, oh, 1 minus the sine squared, that looks familiar. That's one of my Pythagorean identities. 1 minus sine squared of x is cosine squared of x over sine of x. Pythagorean, I'm going to abbreviate that. Then I say, if I divide that up and make that cosine of x over the sine of x times the cosine of x, I just did some algebra. Right? I took cosine squared and made it cosine times cosine. Cosine over sine happens to be my quotient identity. That's equal to the cotangent of x times the cosine of x, using my quotient identity. And now I've got it all simplified into what they wanted me to make it into in one expression. Number 11, I'm looking at that, and that one says I want to end up with secant of x. And so I need to try to simplify that. And I think I'm going to start out looking at that one, since I have two things here, by changing my tangent using one of my quotient ones, because I like to try to get things in terms of sine and cosine. So I'm going to have the cosine of x plus the sine of x times, and in place of tangent, I'm going to have the sine of x over the cosine of x. That is my quotient identity. Then I look at that again and say, okay, if I want to get a common denominator and get this into one expression, I can multiply by the cosine of x. And so I'm going to jump over this little box here, and I'm going to say cosine squared of x plus sine squared of x all over the cosine of x, puts that into one expression. And that was just straight using algebra, because I just multiplied times the cosine of x here and the cosine of x here, and got my common denominator and simplified my expression. So now if I look at my expression, this pops out at me. Sine squared plus cosine squared is 1. So I can make that 1 over the cosine. I probably should have had an x behind there, or it won't like me if I leave my x off. That is going to be my Pythagorean identity. 1 over cosine of x happens to be the reciprocal of the secant. So now I've got the secant of x using my reciprocal identity, and now I have my proof done. Technically, I guess I'm not multiplying by the cosine there. I'm just multiplying here, making my equivalent fraction. I should write it that way, by multiplying by cosine of x over cosine of x. So I get cosine squared of x and sine squared of x over my cosine of x, and have my common denominator. Should probably write it a little better so you know what I'm doing. Now sometimes there's more than one way to solve it, and if you're putting something in and it's not thinking it's working right, Try to do it in a different order. Sometimes it's a little picky at how you put things in, but should work. Number 12, we have tangent squared minus the sine squared, and we want it into tangent of x and sine squared of x. So again, we probably want to start, and I'm going to start anyway, by changing my tangent squared of x in terms of sine and cosine. So I'm going to say that this is the sine squared of x over the cosine squared of x minus the sine squared of x. And I'm just using my quotient identity in order to start that one, because I try to put things in terms of sine and cosine whenever I can. So then if I go ahead here and do my common denominator of cosine of x, cosine squared of x, I'm going to have the sine squared of x minus the sine squared of x times the cosine squared of x all over the cosine squared of x, which is just basically doing algebra, finding my common denominator, making my equivalent fraction. So if I look at this, I can factor this top part out. I can take the sine squared of x out, and I get 1 minus the cosine squared of x over the cosine squared of x. Again, that's just doing algebra. I'm just doing factoring. I'm taking that sine squared of x out of there. One minus the cosine squared is equal to the sine squared, so I can make this the sine squared of x over the cosine squared of x times the sine squared of x. Just replacing that using my Pythagorean identity. Sine squared over cosine squared, that's one of my quotient identities. Sine squared over cosine squared is tangent squared. So I get the tangent squared of x, sine squared of x, which is what I want, by using my quotient identity in order to replace the sine squared over the cosine squared. So a lot of these, if I've got adding or subtracting in, after I've changed them, I'm going to make an equivalent fraction so I have a common denominator, and then do various things in order to simplify. In this case, I had to do some factoring, and then I can get it all simplified into the expression I want.